Hello my dear student, hope you are fine and taking care of yourself at your home, and I hope that you are doing well also and doing practice of all the numericals. You know that in the last video I have explained you about how to find out the expression for the potential energy, and we have derived that formula. Potential energy is equal to mgh. Today we will do the next topic. Before starting the next topic, please do like and subscribe my channel and press the bell icon button. Today we are going to do the topic that potential energy depends on the height from initial position to the final position, and it is independent of the path followed by the object for the same initial and final position. So let's start that derivation. So we are finding today, we are showing that potential energy is same for the two different positions when height is same. So for that, let us consider an object or a body, of mass m. Clear? We will consider it. Let height is equal to h. Clear? So let us see this. These two situations are there. This is the ground level, and from this ground level we have to raise the body from this A position to this height h, and this position is B. Clear? We have to raise this body to here. So we are raising it. So what is the potential energy? This is the path 1. This is the path 1. So what is the formula for the potential energy? It is equal to the amount of work done on the body which is stored inside the body as a potential energy, and that we have done is equal to what we have done in it is the amount of work done. So what is that formula we have calculated? mgh. We have to apply the force equal to weight of the body, and height we have to raise it. So let us take, this is the first equation. Now the same height we have to raise the object but by different path. So like this is the ground level, this is path 2 followed by the body. So this is the first case. Body is here, but instead of getting it raised here directly, we are taking it first from A position to A1 position. Clear? We are raising it from A position to A1, and let us take this height is h1. This height is h1, and after that it moves from here to here horizontally to the A2 position. Clear? And after that it reaches to the same height. That is, it reaches to the same height because we are considering height is same. So it reaches here, the same body, but this time path is different. So this position is B only. So this body reaches to here from this A2 position. So what you are watching in the path 2 and path 1. Path 1 it is directly going from initial to final position, but here what it is following from A to A1, A1 to A2, and then A2 to B. So let us find out potential energy at A1. Potential energy at A1. So we are raising the body, same body of mass m, to the height h1. So what it is? mgh1. So let us take, this is second equation because first we have considered here. Now when the body goes from this position to this position, it is a horizontal direction. It is a horizontal direction. So what is the amount of work done on this against the gravity? So when a body moves horizontally, so what is the amount of work done? Both becomes perpendicular. So from A1 to A2, when it will go, height is same. So there is no change in potential energy. You know that potential energy will get changed. Either mass will change or height will change. But when the body is going from A1 to A2 position, there is no change in height of the object. So there is no change in potential energy. So potential energy at A2 is also mgh1 because height is same. Now what is the potential energy at B? At B. So now the body goes from A2 to B. So what is that formula? mg. What is this height we have considered? This is h1 and this is h2. And this total height we have considered in the starting only. I have told to you that the body is going with the same initial and final position, that is height is h. So we will add these two equations, add second and third equation. So what we will get? Potential energy of the body, total potential energy. This energy at B is from A2. This is from A2. Now potential energy, total potential energy we can say in this case here. So that is equal to mg h1 plus mg h2. Now take mg common, that becomes h1 plus h2. And what is this h1 plus h2? That is h. So mg h. So you have got a fourth equation. By fourth equation and by first equation, you can see that when height is the same, potential energy will remain the same whatever path is followed by the body. But if you will change the height, then definitely there will be change in the potential energy. So in this derivation today, we have proved that potential energy remains same when body goes from initial position to final position, and that remains same, but path changes. So whatever path will change but height is same, then potential energy will remain same. So you have to do practice for this today. Thank you and have a nice day.